For Lab 7 in Introduction to Computer Architecture, we are asked to code a program that will take user input of type string and then look at each individual character, and if the character is an uppercase character, it will convert it into a lowercase character. To do this, we are going to need a while loop to examine every single character in the string. We will also need to get the string's length to use as a breaking point for our loop. And we will also have to use the scan_cstring method from the ASCII 35.0 library. To start this, as always, we need to specify what syntax we're using. We're going to use .intel_syntax with a no prefix. After this, we are going to write .data because we are going to be in our data section. Later, we need a .text section as well, so we can just write this in. We'll have .text and then .global underscore, or there should be a space, and then underscore start. So .global space underscore start, and then underscore start with a colon after it like this. In our .data section, we are going to have this first prompt, which asks the user a question. We then have a new line, and then the ending for this string. When we print out what we change it to, which is the lowercase version of it, we are going to have this, a /n for a new line, and then a /0. We also need somewhere to store our string. So these are just labels with .ASCIIs in them. And then we need a label, we'll call it string. And inside of here, instead of having .ASCII, we're gonna have .space 100. And this is specifying that our string that's being passed in cannot be greater than 100. To keep these clean, I'm also going to add another space at the end, so we'll just have a space label with a new line inside of it. Now we can go into our .text section. The first thing that we want to print is this prompt right here. So we are going to load into RAX rumor, and then we are going to do a call print CString to print it out. After this is done, we can work on now getting the user input. I'm adding this just for spacing because we're going to have a lot in the .text section. And if we go into the ASCII 35.0 library x64 guide, we can see a lot of different things in here, but we want to look in the string subroutine section where we can find scan_cstring. And this says it scans a null terminated string and writes it into the address stored in RAX. The register RBX must contain the number of characters that can be read. So it's saying that we need to write to the address stored in RAX. So we have to load an address into RAX before we start this. So we're going to do load effective address RAX, and we want to store it in string right here. So we're going to have a space in string like this. Next, we need to move 100 into our RBX because it says the register RBX must contain the maximum number of characters that can be read, the size of the buffer. And this is the size of our buffer, so we're just going to move into RBX 100. I space those out more. And after we have both of these written down, we can just call our scan_cstring. So this will scan for any string that the user inputs up to 100 characters. I just added some more notes here. These hashtags, if it starts with a hashtag, it is a comment. So after we have gotten the string from the user, we can actually now get the size, and we're going to use this later in our loop. To get the size, all we need to do is look back into the ASCII 35.0 library and see that we have a subroutine called LengthCString, and this returns the length of a null terminated string stored at address RAX. The result is returned in RAX. So what we can do here is call LengthCString. And after we do this, the instructions of this lab ask us to read each character in the string into an 8-bit register. We need to move this length into an 8-bit register. If we look at notes section part 3 and go down to slide 28, we can see the new 64-bit registers. Or if we look at slide 30, we can see that we have a 64-bit register table. These are the specific bits, and these are the registers we can use. We can use any of these registers because they're 8-bit registers. We're just going to use R8 here since it's the first thing on the table. So we are going to move into R8 RAX. because the call LengthCString stores into RAX. So we'll move RAX into R8. We can test our code by doing a move into RAX our string. So we are passing whatever string the user types in, because it's stored in string, into RAX, and then we are going to use a call print cstring to print it out, just to make sure that we correctly store the user's string into our string buffer. We also want to make sure that we are getting the right size of our string. So when we have our call LengthCStrings, it stores into RAX, then we're moving it into R8. What we need to do here is move into RAX R8 and then call print int. And this move up here should actually be a load effective address. Since we are printing the string that's stored in string, we are loading the effective address of the actual string, which is user input, into RAX and then printing it out. I also have a typo here that I fixed. This should be spelt rumor, since our label up here is spelt rumor. After we have all of this, we can write a call end program, so our program will eventually kill itself. We can do Control X, Y, and enter. I can assemble our program, link our program, and then execute our program. And if we do what is the rumor, we will write testing, and then we see that we have our string printed back out to us and the number of characters inside of it, which is 7. So since that works, we can go back into our code. If it didn't work, we would probably have to modify something around this area or this area. We can actually just keep this in here and then write it as test. It's important to comment these out just to make sure it will not run when we are running our overall program, because we don't need this to output. Now we have our user input in string. We also have the length of our string. So now all we have to do is analyze the specific characters in our string. And to do this, we are going to need loops to go through the entire string. So before our call end program, in between testing values, we will be writing in here. So we want to test if it's a letter first. So we will make the label for our loop test for letter. And the reason why we want to test for a letter specifically is because if we look at an ASCII table, we can just Google this and it'll show a decimal column. It'll also show a character column. We want to only look at the characters between decimal number 65 and 90. This is because those characters are uppercase, and only those characters. Otherwise, we don't need to change it, and we can just loop back through and get the next character and analyze it. So first we need to test if this is a letter. This is going to be our outermost loop. Inside of our outermost loop, we first need to get the specific character we're looking at. So we are going to need to move a byte. And instead of doing move, we're going to do movb, which means move byte. We are moving this byte into AL, which is the A low register, and we are storing it in here. And then we are going to have these brackets with the label that we are storing our string in. We know this to be string right here, so we're going to print string. And then to increment through our list, we actually need a counter that gets incremented every single time this loop runs. So we have to do a plus RDI. And then we want to first get the index of 0 of our string the first time we go through this loop. So before we go through this loop, right outside of it, right in front, we can press enter and get this line right here and set RDI equal to 0. We do this by doing move RDI 0. So now RDI has the value 0. So that means we're getting the character at the 0th index of RDI. This string part is the base. So this is the base string that we're going to look at. In this RDI, we don't have to use RDI. We can use any index that we want, but we're going to use RDI here. It's set to 0, but we're going to increment this every single time this runs. So this is going to get the 0th character the first time, then the first character, second character, third character, and so on until we max out of our length. And we're going to come back to how we're going to end this loop once we finish writing our loop. So after we get our first character, what we need to do is compare this. Since we're using movb, we're getting the actual decimal, not the character. If we were doing the load effective address or print character, we would get the character. But since we're doing this, we are getting the decimal of this character. So we need to compare this decimal to the very first decimal of our ASCII table. And the very first decimal of our ASCII table is 65. So we're going to say we're going to compare AL to 65. And if our AL is greater than or equal to 65, that means it is possibly a character. So we're just going to jump to a new loop. We're going to say jump greater than, and now we need to test for uppercase, because it could also be lowercase or a couple different characters. So we could jump greater than test for uppercase, and then below this test for letter loop, we are going to make a test for uppercase loop. Inside of our test for uppercase, we need to make sure that this specific decimal character is less than or equal to 90, or it's less than 91. So what we can do in here is basically the same thing. We can have a compare, where we compare AL to 90. And if this is less than or equal to, or jump less than or equal to, we can go and jump to change to lowercase, which is just a label that we are going to make. So I made this change to lowercase, and we're going to be in here if we have a uppercase label. We have this first loop that checks to make sure that it is above 65 on our ASCII chart. Then we have this next loop to make sure it is lower than 90, so it has to be between 65 and 90. And if it is, we're just going to jump to change to lowercase. But what if this is not greater than or equal to 65? And what if this is not greater than or equal to 90? What we're going to have to do is move to the next character and go back to test for letter, because we don't need to go through any of these tests. So what we can do underneath our jump greater than equal test for uppercase is write a statement that will increment our RDI and then go back to test for letter, since we won't need to change it at all. So we can do add RDI, comma 1, and this adds 1 to RDI. We'll have a spacing here. We can jump back to test for letter. So we're just going to do a unconditional jump into test for letter. And this is only if our compare fails, only if AL is not greater than or equal to 65. If it is, we're going to be in here. But what if our AL, the current character, is greater than 90? Well, then we don't need to change it. So we're going to do the same thing where we just add 1 into RDI, and then we're going to unconditionally jump back to test for letter. So this is our current loop. Now that we have all of these situated, these should look final, we are going to officially change our character to lowercase. To change our character to lowercase, if we look at the ASCII table, it looks like all we need to do is add 32 to the decimal of our uppercase character. So that's easy. We have the decimal value stored in AL. So all we need to do is add AL, comma 32. So we're just adding 32 to AL. So now AL is going to be worth 32 more. Now we need to move this back into our string. So what we need to do is have a movb, which moves the byte. We are not going to specify AL out here, because if we did, it would move it back into AL, and that's not what we want. We're going to just have our brackets like normal, and we're just going to have string plus RDI. So basically like this up here, except we're not going to have AL because we don't want to move it into AL. We want to move it back into string, and we are just moving into string at the specific index. Currently our index is 0 if we are starting from the base. And then we will have a comma AL. And what this does is it moves this argument AL into the current index of this string. So we have AL being moved into the index of our string. And then after we have this, we still have more characters in our array, possibly. So we are going to have to add into RDI 1 and then loop back to test for letter, because we need to test the other letters in our string. So we're going to add 1 to RDI and then do an unconditional jump to test for letter. This is now all of our current loops, all of our current statements, and we eventually need to break out of this loop, because right now it's an infinite loop. what we can do is actually have a space right here and write code that does this. We only want to run this the length of the string. So what we can do is compare the length of the string, which we stored in the R8 register, to RDI, because RDI starts at 0 and is incrementing every single time. If it reaches the same number as our string length, which is stored in R8, then there's nothing left to analyze and we need to break out of this. That's why we're comparing. And then if our RDI is the same as our R8, we need to jump to the end of our program. So we can say jump equals end program, and we will make a label that's called end program. This is only going to happen if R8 is equal to RDI. So down here I will have another space, and this is our entire loop right here. This is the biggest part of our program, and now we can write the finishing part of our program. Well, we need to print out this change first. It's basically a prefix to what we're printing out. So we need to load the effective address of change into RAX and then print it out. Then we need to print out our string that has been modified and then a space just for spacing. So back down here, we need this label end program, call it end program like this. And then when we're loading the effective address of our label called change, and then we are just going to call print CString. After we do this, we want to load our string and print it. So we're going to load the effective address into RAX, our string, and then also call print CString. And then just for spacing, we are going to load the effective address of space into RAX, and then call print CString. And then we can end our program by doing a call end program. And this is our entire code. So if we go back up here, we can take a look at it. We first have these comments right here that just tell us what it's doing. We are specifying the syntax. We have our .data section, and we have these prompts or prefixes in here that we're going to just simply print out. We have this, which stores our string up to 100 characters, and then we just have a spacing up here. Next, we're going to be in our .text section. So this basically just prints this first part. After we do this, we need to scan the user string input. So we need to load the effective address of our buffer, which is string, into RAX. And then we need to specify the size in RBX. So we just move 100 into RBX. After we call our scan CString, it's going to store the string into the buffer that is associated with RAX. And currently that is string. So now string, this part right here, holds the user input. We need to get the string size. To do this, we call LengthCString, and then after this, it's going to store into RAX. So we want to keep this value. That way we can use it later for a loop. So we're moving RAX into R8. This part right here, it just tests if we are getting our string and our size correct, which we did. So then we moved on. This is the start of our loop section. So we have our counter right here that's going to get incremented every single time this loop runs. It starts out at 0. That way we can go through our entire string length. We are going to first compare our R8, which is our string length, to our RDI. And if they're equal, it's just going to jump to the end of the program because there's nothing left to analyze. To get the specific character, since we need to analyze each character individually, we need to move the byte into AL. So we are doing movb, which means move byte, and we are moving it into the small address AL. We are going to get the string, which is our base. This is the user input. And then we are getting the index of this string, which is currently 0. Then we need to compare this character to 65 and look at our ASCII table. If the character is less than 65, we are not going to go into this jump statement, and we are just going to add 1 to our RDI, jump back to test for letter, which is right here, and then either jump to the end or get the next character in our string. If our AL, which is a specific character, is greater than 65, we need to jump to the next case, which tests for our uppercase right here. We are going to compare AL to 90. If it is less than 90, that means this has to be uppercase. So we're going to jump into our change to lowercase label. If not, we are going to add 1 to RDI, which basically increments the index, and then we're going to jump back to test for letter up here. where we will either end the program or move on to the next character. Interchange to lowercase, we need to add 32 to our AL. Since our AL isn't actually storing the character, it's storing the decimal that this character is located at. If we add 32 to it, that means we are going to get the lowercase version of it. And then to move this back into our string, we need to move B instead of move, because we're only moving a specific byte, into our base, which is string, and then we need to specify the index right here. And then we need to have a comma, what we're moving in, and what we're moving in is our new AL. And then next we need to analyze the next character. So we're going to add 1 to our index, and then jump back to test for letter, where we will be up here and either end the program or get the next character and analyze it. That is our entire loop right here. After we jump out of our loop, we're going to go into this end program label, where we print out the first part of our prefix, then we print out the new string, and then we're just going to print out a space and end our program. I did have a misspell right here where my T was lowercase and it should be uppercase, because we have it as an uppercase here, so just a small spelling error. I also need to put a semicolon right here, so if we'll go to the end right here, add a colon. Another thing that I found of error is when I called end program like this. You cannot actually make a label called end program, since we have something that's called end program. So if we jump to end program, it's going to give us it should give us a infinite loop, and this is not going to work. So we should just change our label title. We can change this instead of end program to just end. So we're going to jump equals to and then end. We'll change this down here, and so this is just end. I can assemble our code by doing as-o lab7.o and lab7.asm, o before m, press enter. We can link this by doing ld-o a.out lab7.o and csc35.o. Pressing enter, we have no errors with our linking, so we can just execute by doing /a.out and press enter. We can test this by doing testing, throwing in a few different values, even numbers or symbols, and pressing enter. We can see that it changes it all to lowercase and does not touch anything that is not uppercase or already lowercase. And that is the correct output for this code.